Hi, Year 13. Today's mechanics lesson is on inclined planes, some of which we started very briefly last week, but I want to move it forwards today. So I want you to have a look at this slide if you need a bit of a reminder as to what we did. So basically, questions are going to involve objects sitting on inclined planes, so at some kind of nice angle normally, so 30, 45, 60 is what it usually is. And you've got to make sure that any force that appears in your diagram is acting in the nice directions that we can resolve in. And those directions for now are going to be parallel to the plane, so this direction along that way, or perpendicular to the plane, which is coming out that way at a right angle. Okay, so we're going to start off by just reminding ourselves how we label these things up. So if our block has a weight of a mass of 3 kilograms, then its weight will be 3g, and that's gravity, so it acts vertically downwards. Then, because that's not in the directions that I just spoke about, we need to split this off into its components. So here's the one perpendicular to the plane in blue, and there it is parallel to the plane in red. Now, we said that the angle that the plane is inclined at, so 30 degrees, is going to end up at the top of this right-angled triangle, and you can think about why that is, and maybe give yourself an argument. Spoilers, there you go. So 30 degrees goes in there. Then using some trigonometry, you can get the blue and the red. So the one that's snug with the angle is cos, so 3g cos 30, and then the opposite side is using sine. Okay, now because it's 30, you are welcome to change these out for their exact values, but I'll leave that up to you, okay? It just makes it a bit tidier when you do your calculations. After that, so your block is resting on the plane, so you're going to have a normal reaction force coming out like that. And that's about it. So any other force as well, if you're pushing this block at a particular force, make sure you're resolving into those directions as well. Okay, so let's see a question on this then. All right, so if you're not given a picture, chances are you're going to want to draw one so that you can start to put these forces on and get a nice diagram. But here's the description. So a box of mass 2 kilograms is resting on a smooth plane inclined at an angle of 20 degrees, and it meets resistance of 2 newtons as it travels down the slope. Now, it's put the word smooth in there because we haven't come across friction yet. So we're going to leave that maybe for next week. So for now, you don't need to worry about putting any friction on or worrying about how to calculate it. So let's draw a picture of this setup, and then it's going to ask us to do this stuff. So the acceleration of the box down the slope. And then if the box starts 10 meters up the plane, it wants the velocity at the bottom of the plane. Now that second part looks very Suvat-y to me, so we'll kind of see what happens when we get to do that one. Okay, right, here's your picture. So we've drawn in the 20 degrees, we've got a 2 kilogram block, and now you can fill in all the forces. 2g that way, then 20 degrees jumps into there, 2g cos 20 for opposite, adjacent, 2g sine 20 for opposite. So here's going to be the 2 newtons. You just got to use your common sense as to which way these things are going to point, right? If your block is traveling down the slope, the resistance is going to go up the slope. So make sure you point it the right way. Okay, now there is going to be a normal reaction force as well, but the question isn't particularly asking about it just yet, so we can draw it in at least, but we don't really need it for this question. If you did want to work it out, it turns out it's going to be equal to this force here of 2g cos 20, but it's not needed. Okay, right, that's enough to start the question. We don't need to put any friction on, as I said. So we're now going to resolve in the nice directions that we've got. So I think it makes sense to do parallel to the plane. And that's seeing as the acceleration is going down the plane, right? If we haven't drawn an acceleration, so let's put that on. It's traveling down the slope. So acceleration goes this way. Okay, that's in meters per second squared. And if we resolve towards this direction, that's going to keep our unknown values positive. So let's do that. So down the plane. 2g sine 20, this red one here, goes down in that direction, and then it's minus 2 because that goes up. That's the sum of the forces, and then it's mass times acceleration. Okay, this is Newton's second law. And then it's just a matter of solving for A. So you collect together, tidy up, divide by 2, and it's 2.4. Okay, meters per second squared. Right, so let's keep that value safe because we're going to maybe need it for the next part. So as I said before, this kind of question that's talking about displacements, times, velocities is going to be some kind of Suvat question. particularly because our gravity that's acting on our object is a constant acceleration, and that's the only time that you can use suvat. So let's write down what we know about suvat then. S is 10, U is 0, because it starts from rest. You need to double check that in the question. Yep, resting tells us that U is 0. V is the thing that we actually want. A is 2.4, that's calculated in part A. And then T we don't know, but it's not needed to do the question, so we're going to kind of ignore T. Right, based on these 4 values, you've got to think about which of the 5 suvat equations fits that best. And the one that doesn't have T in it is this one. Okay, hopefully you're getting some familiarity with these. So V squared is U squared plus 2AS. Sub the values in. Make sure that these are firstly pointing in the right direction and they all have the correct sign. If we're resolving down the plane, as you should be, then these are all going to be positive. Okay. Sub them in. Tidy up. And then V squared is 47 and a bit. Square root it, and V is 6.6 meters per second. Okay. So that's pretty much what you typically get in a question. We are going to start to add in some more forces to this picture, and then we're going to do friction after that. Okay, let's have a look at one more. There's unknown angle here. So again, we've got particle in equilibrium. Remember that means that all the forces in each direction cancel out. So you can start to equate forces in different directions. And here's our setup. The particle's in the middle. We've got its weight down there, 5 newtons, an angle of 30. And they're all pointing in kind of strange directions. Let's get them all consistent. So what we want to do is split our P and our 5 newtons into the directions that are parallel and perpendicular to the plane again. And then eventually we want these unknown things, right? We want angle theta and the force P. So that's splitting off into parallel and perpendicular. P cos theta, P sine theta. The 5 newtons splits up like the last one, 30 degrees in there, 5 cos 30, 5 sine 30. Then resolving parallel to the plane. So parallel is the red direction. Because our unknowns are up here, it makes sense to resolve upwards, and that keeps our unknowns positive. So again, F equals ma. All right, now the way that it's done it in here is that it's saying that the acceleration is 0, okay? Because it's in equilibrium, what's going to happen is these things are going to cancel out. So the upward force minus the downward force is, because there's 2 of them, equals 0, okay? Another way to do it is just to go straight to upwards equals downwards if you know it's in equilibrium. Right, there we go. Make sure you've got all of the forces in that direction and they're pointing the right way. And then we can't really simplify anything past here, so let's just keep that separate. And then with our blue equation, we can kind of solve it against the other one. So perpendicular, we're going to resolve away from the plane like that. Same as before. So you've got P sine theta plus 2 because of this extra 2, and then minus 5 cos 30 equals 0. And that rearranges, and it's going to go off the screen, but it ends up there. Right, so we've seen these kind of equations before with a sine theta and a cos theta. Hopefully you remember what to do from last time. Write them next to each other, and then if you divide through, you can clear away p's. That leaves tan theta. And then on the right side, just make sure that you're dividing the whole thing by the whole thing. Okay, you can't split these into separate columns. It's going to be one big fraction like that. And then that's all just constants, you can work that out. And then inverse tan gives you this angle. Okay, so theta is 12.5 degrees. You can use either of these equations here, sub in your value of theta, and you can work out P. Okay, so that's putting it in there. It's divided it by cos theta to put it over there. Sub the value in and work it out. 10.8 newtons. Okay, all right, so hopefully that gives you a pretty good idea of what to do. Just be careful about, again, which way things point and using the correct trig value for each of these things. All right, thanks year 13, and best of luck with today's work, and I'll put what you need to do on Show My Homework.